Richard James will present fraction tutorial 3. The first problem that we have in this section has no mixed number. So with no mixed number, let's get straight to the contents of the brackets. Remember that operations enclosed in brackets take precedence over the others. Inside, we will reciprocate the divisor and change the division sign to multiplication. Also, reduce the fractions by a common factor of 3, which is quite a mouthful. So what we will do is do the reciprocal of this fraction that we are dividing by. As a matter of fact, these are enclosed in brackets, so we need to do them first. Not that we had to have them enclosed in brackets, because division takes precedence over addition, so we will normally divide first. But it helps, it is helping us, or should, by having them enclosed in brackets, saying that we need to actually do those operations first. So we have 1 over 7 here, 2 over 3 there, and 12. As a matter of fact, the original one, 11 over 12 there. And what do we do? Do the reciprocal and change the sign to multiplication. In addition to that, we will reduce by a common factor of 3. So 3 into 3 is 1, and 3 into 12 is 4. Now we will have 1 over 7 plus the result. So we will finish this process by multiplying the numerators. 2 4 is 8, and 1 times 11 is 11. So we have the 1 over 7 right there, and then we have the result of the fraction reduction right here, which is 8 over 11. Next, we will add the resulting fractions with exclusive denominators. So we have 1 over 7 plus 8 over 11, and we will find the result of that addition by making use of the fact that the denominator of the answer will be the product of the two denominators. 7 times 11 is 77, and we go like that. 11 times 1, 11, and 8 sevens, 56. And we will finish up by adding 11 plus 56, and that is 67. And that will be placed over the denominator of 77. So we figure, after all, that the entire explanation of this problem is pretty straightforward. 67 over 77. The next one. It is like we cannot stay away too long from those problems that require that we convert mixed numbers to improper fractions, so let us go straight to it. So the first mixed number is 2 and 1/3. 3 2s, 6, and 6 plus 1 is equal to 7. 7 is our new numerator, and we have the same denominator. Then we have 1.5, 3 over 2. So 2 times 1 is equal to 2, and then 2 plus 1 is equal to 3, and that is the new numerator, and the denominator is the same. So we say now 6 1s 6, 6 plus 5, 11, 11 over 6. What do we do next? The upper set of fractions will be enclosed in brackets, and the large fraction bar replaced by a division sign, as usual. We always do that in those or under those circumstances. We will find the difference between the two fractions by making use of exclusive denominators, and we will find the reciprocal of the divisor, at which time we will change the division sign to multiplication. What do we do? These two fractions, find their sums. We have exclusive denominators, meaning that the denominators do not have common factors. When that is the case, we will find the difference between the two fractions by making use of the fact that the new denominator will be the product of the two denominators. 3 2s, 6. Then we have another one, 2 7s, 14 goes there, and 3 3s, 9 will go there, accompanied by the negative sign. 3 3s, 9. Lovely. And then we will do the reciprocal of the divisor and replace the division sign with a multiplication sign. And of course, 14 minus 9 is equal to 5. So let us move merrily to that on the next slide. Find the difference between the two numerators of the fraction, or the two numbers that are in the numerator of the fraction, and proceed to reduce the fractions by a common factor of 6. So we have 14 minus 9 is equal to 5. And what do we do? Because 14 minus 9 is 5, the new fraction is actually 5 over 6. 5 over 6. And that we multiply by 6 over 11. By doing what? Those two 6's will take care of each other, reducing by a common factor of 6. But we can see that the 6's will cancel. And the result is 5 over 11. There is no large fraction bar as we have in this problem, and we can see right there that we do not have any large fraction bar in this case. Let us convert mixed numbers to improper fractions in this step. The first set of fractions are already enclosed in brackets, so we do not have to do that, and we do not have any fraction bar, and there is no large fraction bar as we have it right there. So some of the steps are the activity in the first step is reduced. So improper fraction, so we have 7 1 7 plus 1 is 8, 8 over 7. The denominator is the same. Hopefully we have more, yes. So we can say 3 2s, 6. 6 plus 2 is 8. 8, and the denominator is the same. One of the mixed numbers is repeated, and we do not need to do a second take in converting it to improper fraction. So we do not have to go ahead and do this one also, because this one and this one are the same. We will use the process of addition of exclusive denominator in adding the fractions and reciprocate the divisor, while at the same time replace the division sign with a multiplication sign. So we are adding those two by making use of the fact that we are saying that those are exclusive. So they do not have common factors. So the new denominator will be the product of those two denominators, 21. Then we say 8 3s, 24. Then we say 8 7s, 56. And we are about to reciprocate the fraction that we are dividing by, replacing the division sign with a multiplication sign. We will also add these on the next slide. Add the numerators of a fraction and reduce the fraction by a common factor of 8, followed by a common factor of 3. So if we are reducing by all of 24, we imagine that the fraction or the resulting fraction will be small. So we have 24 plus 56, these two numbers equal to 80. So 80 over 21 multiplied by 3 over 8. So 8 into 8 gives 1, and 8 into 80 gives 10. So what do we know? Another common factor of 3. 3 into 21 is 7. and 3 into 3 is 1. And we finish up as usual by multiplying 10 ones 10 and 7 ones 7. Well, we predicted that it would have been a small fraction. Not so small, not as small as we imagined. Now, our situation is different. I always welcome something that is a bit different from the regular flow. So we are saying that subtracting 1/3 from 3 may be done mentally. Even easier is adding 3 and 1/5. So if we add 3 to 1/5, we get 3 and 1/5. That is easy. And we are saying that if we have 3 cakes and we need to take 1/3 of a cake away, we have 2 and 2/3 left. That's not very difficult. So let us convert the resulting mixed numbers into improper fractions as if we did not know that we would have eventually gotten to it. So we have 3 minus 1/3 is 2 and 2/3, and we have 3 plus 1/5 is 3 and 1/5. As I said before, let us convert them as if we did not know that we eventually would have gotten to it. Because some of us were saying, okay, good, now that we are doing this, we don't have to go through all of that. But they say lightning does not strike twice in the same place. But that is refutable, because no matter where we go, we all return to the same thing, converting mixed numbers to improper fraction. So we have 3 to 6, and then plus 2 is 8, 8 over 3, and then the other one is 3 5s 15 plus 1 is 16, 16 over 5. And you know what we will do on the next slide. Here we will invert the divisor and change the operation from division to multiplication. We will then reduce the fraction by a common factor of 8. Alright, let's see what we have right there. If we have a large fraction bar, we have replaced the fraction bar already with a division sign. So all we need to do now is reciprocate and change that to a multiplication sign. And that we are doing now after converting those mixed numbers, the results that we have right there, to improper fractions, and we will reduce by a common factor of 8. So 8 into 16 is 2, and 8 into 8 is 1. So all that we have is 1 multiplied by 5 is 5, and 3 multiplied by 2 is 6. All we have there is 5 over 6. Nice. There we have another circumstance. We have 2 mixed numbers in the expression, but one is subtracted from a whole number. Right, we have one of them subtracted from a whole number. That is a simple mental process. We will convert the other one to an improper fraction. We will also enclose the upper set of fractions in brackets and replace the large fraction bar with a division sign. We have 2 mixed numbers here, but we will only convert one right now. Maybe we do not have to convert another. We have this whole number from which we are subtracting the other mixed number, which is a simple process, so we do not have to change this to an improper fraction. So let us go straight ahead and do that one. 7 times 1 is 7, and 7 plus 2 is 9, so that is 9 over 7. What do we do next? In subtracting 2 and 2/7 from 3, we may operate as if we have 3 cakes on the counter. So there we have our 3 cakes on the counter. Right, I have painted them blue so that you will not eat them. So there we have our 3 cakes on the counter. take away 2 and 2/7 means that we need to take away 2 and we need to take away 2/7. So let us first take away 2. And then after taking away 2, what will we do next? There is an entire cake that is left. Let us take away 2/7 from that cake. 2/7. So if we take away 2/7, that's what happens. There we have it. We only have 5/7 of the cake left. Although the fractions are approximations, yes, it's approximately 2/7. I'm saying, I am sure that the approximations are not outrageous, because 2/8 is a quarter. Therefore 2/7 should be a bit greater than a quarter, and we have it depicted right there. So notice that we have it a little bit greater than a quarter that we have taken away, and that is the result. So taking away 2 and 2/7 from 3, we will only have what left? Only 5/7 left. Let us continue on the next slide. In subtracting 2 and 2/7 from 3, we may take the approach of converting one of the whole numbers to 7/7. So we have 3 minus 2 and 2/7. So this 3 is written as what? 2 plus 1. But that 1 is written as 7/7. Subtracting the whole numbers, we have 2 minus 2 is 0, and we still have 2/7 to take away from 7/7. So 7/7 minus 2/7, and that will give 5/7. Adding or subtracting fractions that have the same denominator. Adding or subtracting fractions that have the same denominator will turn out to be some of our favorite activities from primary school. We just add or subtract the numerator, and the denominator will be the same as the common denominator. There we have it. So 7/7 minus 2/7 is 7 minus 2, which is equal to 5. So 5/7, because we are using that same denominator. Do not fall in the trap that I consider to be a new development in mathematical errors. When subtracting a mixed number from a whole number, students subtract the whole numbers and invariably add the fractional part to the remaining whole number, if any. This will be demonstrated when the example is more clear-cut. So we have a new development in mathematical errors, where if we are subtracting, say 3 subtract 2 and 2/7, we take away and we get 1, and then we add the 2/7 to it, so we have 1 and 2/7. We know that any number divided by itself will result in 1. Conversely, 1 is equal to any number divided by itself. It is therefore convenient to write 1 as a particular number divided by itself. The number that we should choose should be equal to the denominator of the fraction. Therefore, if we are subtracting 3/4 from 7, we should remove 1 from the 7, so 7 is equal to 6 plus 1. We will therefore write that 1, which is this one here, as 4/4. Why 4/4? Because the fraction that we are subtracting has a, or we are adding, has a denominator of 4. Because the fraction that we are subtracting has a denominator of 4. So we have 6 and 4/4. So 6, 4/4 is 1. So this is actually 6 plus 1 is 7. So 6 and 4/4 minus 3/4. So we are saying 4/4 minus 3/4 is 1/4, and the 6 is not affected. So we have 6 and a quarter. So let us say that 7 minus 2 and 3/4 is the problem that we have. That is the problem that we have. 7 minus 2 3/4. We may write 7 as 6 plus 1 and then further write 1 as 4 over 4. Then we say 7 is equal to 6 and 4 over 4. From that we will subtract 2 and 3 over 4. So 7 minus 2 3/4 is written as what? 6 and 4/4 minus 2 and 3/4. So we have 6 minus 2 is 4 and 4/4 minus 3/4 is 1/4. So 4 1/4. So subtracting the whole numbers, we have 6 minus 2 is equal to 4. 6 minus 2 is equal to 4. And then we will have 3 over 4 that we are subtracting from 4 over 4. So subtract the whole numbers, we have 6 minus 2 is equal to 4. Remember that 7 was disintegrated into 6 plus 1. Right. So this 7 is actually 6 plus 1. And this one is written as 4 over 4. So 6 and 4 over 4. Minus 2. So we subtract the whole numbers and we end up with 4. Then we need to take the 4 over 4, take that 3 over 4 from it, and we get 1 over 4. So we have 6 minus 2 is 4, and then we have 1 over 4. So we have 4 and 4 over 4 that we are subtracting the 2 first, and then we need to subtract the 3 over 4. So we have 4 over 4 minus 3 over 4 is 1/4. And then we have this additional 4 there, so 4 1/4. So subtract 3/4 from 4 over 4. The result is 1/4, and we still have that 4 whole numbers remaining from the subtraction of the whole numbers. Follow the example that we are about to put on the slide. Let's see if we can follow that. We have 10 minus 3 and 2/5. 10 minus 3 and 2/5. We write the 10 as 9 and 5/5. 9, 5 over 5 is 1. So 9 plus 1 is 10. So we write the 10 as 9 and 5 over 5. And we take away 3 and 2 over 5. So 9 minus 3 is 6. And 5 minus 2 is 3. So we have 6 and 3/5. So 6, 9 minus 3 is 6. Then we have 5 over 5 minus 2 over 5. And that is, we are subtracting 2 over 5. So 5 over 5 minus 2 over 5, and the result is 3 over 5. So we have 6 and 3 over 5. We have 7 cakes, and we need to subtract 2 and 3/4. So we have our 7 cakes, and we need to subtract 2 and 3/4. Let's go straight ahead and do that. If we subtract 2 cakes, we still have another 5 left. They are gone, and we still have another 5 left. From one of those 5 cakes, we need to subtract 3/4. Can we do that? Yes. Subtract 3/4. What do we have left? 1, 2, 3, 4 cakes and 1/4 of a cake left. So 4 and 1/4 cakes are left. So there we have 4 and 1/4 cakes left. If we are solving the problem by making the common, the uncommon. So if we are solving the problem by making that uncommon error, let us see what will be the result. So make the uncommon error and see what the result will be. Make that uncommon error, which is, remember that uncommon error? Subtract the whole number part and add the fractional part to it. So there we go. Subtract the whole number parts. So we have 7 minus 2 is 5. And then what do? Add the fraction to it. 3 over 4. So we have 5 and 3/4. I do not know where we develop these errors from. If we are subtracting 2 and 3/4, it means that we are subtracting 2 and we are subtracting 3/4, because we are subtracting 2 and 3/4. But some students bet to differ and they add the 3/4 to the result of subtracting the 2 whole numbers. Very nice. See how outrageously different our answer is from what it should be, with those cakes staring us in our faces, and yet still you have 5 3/4. That's very nice. So add the fractions with exclusive denominators, then invert the fraction, which is the one that we are dividing by, the one that we call the divisor, and change the division sign to multiplication. Remember that for exclusive denominators, the new denominator will be the product of the two denominators. 3 7s 21, and then we have 2 7s 14, and then we have 9 3s 27. Nice. And then we do the reciprocal. Right. So we need to add these 41. Add the numerators and reduce the fractions by a common factor of 7. So 14 plus 27 is 41, and that we put over 21. And then we will reduce the fractions by a common factor of 7. So 7 into 21 gives 3, and 7 into 7 is 1. So we have 41 times 1 and 3 times 5. So we have 41 over 15. So we say finish up by multiplying the resulting numerators and denominators. 41 times 1 is 41, and 3 times 5 is 15. We will finish this section with a problem which requires the threefold action, and we know what the threefold action is. Convert mixed numbers to improper fractions, replace the large fraction bar with a division sign, enclose the upper set of fractions in brackets. And for the 100th time, let us convert a mixed number to improper fraction. So 7 2s 14. 14 plus 1 is 15. 15 over 7. What about another one? Do we have another? Yes. Hopefully we do not have any other after this one. We have what? 7 1s 7. 7 plus 6 13. 13 over 7. Very nice. Then we will make use of exclusive denominators on the other slide by subtracting the fractions. So we have the new denominator will be the product of these two denominators. So 7 3 is 21. 21 will be the new denominator. Then we say 15 3s. That's 45. Then we say 1 7. That's 7. And we are about to do the reciprocal of this, replacing the division sign by a multiplication sign. And then what do we do? Find the difference between these two. So we will finish this problem and the entire section by reducing this fraction by a common factor of 7. But we need to say 45 minus 7 is equal to 38. So 38 over 21 multiplied by 7 over 13. 7 into 21 gives 3. 7 into 7 is 1. So we will have to complete this by saying 38 multiplied by 1 is 38. And 3 times 13 is 39.